My name is Aaron Hubman, and I am here to show you my program Visual Primes. The purpose of Visual Primes is to make prime numbers easier to understand for anybody, especially those who are visual learners. Visual Primes was programmed in Python with the Turtle library imported and can be run in idle or in the console. Let's see it in action. Here is what the program looks like running. First, it asks us if we want to render the graph being the graph of the rate of primes to composites in the first 1,000 or so numbers it checks. For this run, we'll do the graph. Now it asks us where we want the program to cut off at. So let's do 1000 because that's going to put the end of our graph just off the screen. Now we wait as it draws the graph lines. Now as you can see there, it's drawing the graph. And that's that. This graph is a stair-step graph which is generated in real time as the trial division algorithm runs. Every time a prime number is found, the y increases by 1 pixel. Every time a composite number is found, the x increases by 1 pixel. If you look closely at the graph, you can see that it's not entirely straight. There's small deviations like flat spots here and steep spots there. By the way, the graph lines are at every 10 pixels. Of course, the program can check more than just 1,000 numbers for primes. If we run it again, let's say no to the graph to make it go faster. Let's check 1,000,000 primes. We gotta wait for it to think a little bit. And here we are. All of the prime numbers between 2 and 1,000,000. 78,498 prime numbers. And that's that. Visual primes has a significant impact in this modern world where so many things on the internet are encrypted using large prime numbers. It is a simple way to make a complicated math concept easier to understand.